In this video, we're going to talk about differentiation and integration of exponential function. The main rule you need to know is rather simple, that the derivative with respect to x of e to u, where u is a function of x, is e to u. You get back what you start with, times the derivative of u with respect to x. For example, the derivative with respect to x of e to the x squared plus 5x is e to the x squared plus 5x times the derivative of that exponent, 2x plus 5. That's the derivative of that. Let's try another one. Suppose you were asked to find the derivative of e to the 1 minus x squared. The derivative of e to any power, I don't care what the power is e to that power, times the derivative of the power, which is negative 2x. Suppose you have y is equal to e to the negative x plus e to the x raised to the 7th power. Well, the derivative of the left side is y prime, that is dy dx. The derivative of the right side, well, it's a function to a power. You keep the function the same, bring down the power, make the power 1 less. Remember, that power can only be a real number, not a function of x. Okay, so you brought down the power, you made the new power 1 less, and like always, you take the derivative of what's inside. You can look here or here. They better be the same. And the derivative of e to the negative x is e to the negative x times the derivative of negative x, which is minus 1, plus the derivative of e to the x, which is e to the x times the derivative of x, which is 1. There's no point in denoting you're multiplying by 1. I hate leading terms having a negative sign, so I'll put this first, but I'll write the e to the x first. E to the x minus e to the negative x times their function to that 6th power. There's no way you're going to miss that negative sign. If you put it in front, sometimes you can miss it. Okay. Suppose you were given this function to find dy dx for. 2 over e to the x plus e to the negative x. Whenever you have a product or a quotient and one of the functions is just a constant, don't use the product rule, don't use the quotient rule. In this case, we should rewrite it. Remember that this denominator is to the 1st power. Now if we move it to the numerator, the sign changes. But now, just like the last problem, we have a function to a power. So dy dx or y prime will be, keep the function the same, bring down the power, make it negative 2, make the new power 1 less, and then take the derivative of what's inside. It's a sum, so we take the derivative of the 1st term, and then we take the derivative of the 2nd term. The derivative of the 1st term is e to the x. That is, the derivative of e to the x is e to the x plus. Now the derivative of e to the negative x is e to the negative x times negative 1. So that plus just becomes a negative. Now this term, this factor having a negative exponent and it's in the numerator, I'm going to put it in the denominator and I'm going to change the sign to positive 2. And then the 2 I'm going to write down, and then this. but I'm going to do negative this. So I get e to the negative x minus e to the x. If you have a negative in front of a subtraction, just reverse the subtraction. And there's no more negative sign. Okay, and there's a nice representative of the answer. Now, let us try the next problem. Suppose you come to know that y is equal to x squared e to the x cubed plus 7x to the fifth times e to the x cubed. What's probably best to do is to factor out. So let's look at this. We have to take, as of right now, we have to take the derivative separately. And this is a product rule. So we're going to have to use a product rule to take the derivative of this, plus we're going to have to use, this is also a product. So we're going to have to use a product rule to take the derivative of that. But pretty easily, we can factor out the e to the x cubed, and now we only have one product. So now we'll take the derivative. The derivative of e to the x cubed is e to the x cubed times the derivative of the exponent. That's the derivative of the first times the second. Plus, just the first, e to the x cubed, times the derivative of the second factor, which is 2x plus 35x to the fourth. Now, in both of these terms, they both have a e to the x cubed. And then you have this times that left over. Let us distribute 3x to the fourth plus 21x to the seventh. Plus, we factored out this, so we have that left. And the last step would be to combine like terms. 3 and 35, well, that's 38x to the fourth. Now, just want to make sure that was a 7, plus 21x to the seventh, plus 2x. And that's a nice answer. Let us try another one. Suppose you're asked to find, let's actually write it down, find dy dx. And you're told that the equation is x e to the y minus 3x is, say, equal to 2y. Take the derivative of this minus the derivative of that equals the derivative of that. But the first one is a product. Okay, we use the product rule with respect to x. The derivative of x with respect to x is 1 times the second plus the first times the derivative of the second. The derivative of e to the y with respect to y is e to the y times dy dx. Maybe I was too quick in putting the parentheses. E to the y times dy dx minus the derivative of 3x with respect to x is 3 equals the derivative of 2y with respect to y is 2 times dy dx. I'll just clean this up. Multiplying by 1 doesn't matter. Plus you have x e to the y dy dx minus 3 equals 2 dy dx. I will bring this term to the other side. So the left side, it has this minus that, and fortunately that's all it has. So it's e to the y minus 3. Now, we know we're collecting dy dx is on the right side. So far we have 2 on the right side, and when we bring this number over, it's going to become minus. So we have 2 minus e to the y dy dx's. But once you have a multiple of dy dx, and you want to solve for dy dx, divide by how many you have. 2 minus x e to the y. So this e to the y minus 3 over 2 minus x e to the y is equal to dy dx. And there is your answer. Well, we do one more derivative. Y is equal to x squared e to the negative x. Okay, so this is a product. Use the product rule. Y prime is the derivative of the first, which is 2x, times the second, e to the negative x. Plus the second, x squared, times, first I meant to say, times the derivative of the second. Well, the derivative of e to the negative x is e to the negative x times the derivative, which is negative 1. This negative sign can come here and make that negative. So, as always, we're gonna have e to that power to factor out. What's left over is 2x, a minus, and an x squared. If you like, you can factor out an x here, so you get 2 minus x, and this has a negative exponent, you can put it on the bottom. For the record, if you chose to, you could have written this y as x squared over e to the x, and then used the quotient rule. Either one would have been valid. Now let's see what happens. Integration. The integral of e to the u du is just e to the u plus a constant. Okay, so that's the rule. You have to know this rule. If you have an exponential function and you don't, an integral, and you, let's say it more clearly. If you're taking the integral of an exponential function and you don't know this rule, you're not going to get it right. So we have the integral of e to the x squared 2x dx. Generally, not always, but generally, let u equal the exponent. Okay, if the exponent is just x or t or u or v, then don't bother. But if it's more complicated than that variable, like x plus 3, x squared minus 9, call it u. du is 2x dx. Well, I circled u. That's e, so I use that part. Have to use everything. What's left over is 2x dx. How lucky, that's du. But this integral, I know. It's the one that I'm going to memorize. One that I did memorize. Okay? I'm going to know that one. This is e to the u plus c. Now, don't think you remember what u is. Be sure. Go back and read it off. It's x squared. Okay, so that's the integral. The integral of e to the x squared times 2x dx is e to the 2x plus or c. Okay, let's try another integral. Suppose you have the integral of e to the negative 2x dx. Like I suggested, let u be the exponent. So then du will be negative 2 dx. So that part, well, that's e to the u. and what's left over is dx. But I need negative 2 dx to call it du. Well, if you just need a number, not a variable, just a number, you can put in a negative 2, but then you better multiply by its reciprocal. It's negative 1/2 times negative 2 is 1. That's okay. So here's the negative 1/2, and now negative 2 dx, ooh, that's du. Oh, this worked because I know this integral. So the answer is negative 1/2 e to the u plus c. There's no reason to say that this integral is e to the u plus c, and I multiply the whole thing by negative 1/2. Yes, negative 1/2 times e to the u is this. Well, negative 1/2 times c, well, that's just a different c. You know, call that script c. You know what that script c equals? Negative 1/2 of the initial c that, or the c that I have there. It doesn't matter. It's still an arbitrary constant. Okay, so plus c. E to negative 1/2 e to the u plus c, but then you should substitute back in what u is. It's negative 1/2 e to the negative 2x plus c. If you like, since that's a negative exponent, or if your teacher says absolutely no negative exponents in the final answer, you can bring this from the numerator to the denominator, as long as you change the sign of the exponent. Now, if you noticed, the answer, negative 1/2 e to the negative 2x. And let's look at the beginning problem. Remember, what's in the pink wasn't there. So you have e to the negative 2x, and that's the answer. And then we divided by negative 2. We divided by negative 2. Because multiplying by negative 1/2 is the same as dividing by the reciprocal. That is, there's a formula. It's a simple formula to derive. If you have e to the kx dx, let u equal to kx, the derivative of a constant times x is a constant, so the differential will be du equals k dx. Well, this here is u, so this part is e to the u. But there we go again, I need k dx. Well, you can put the k in as long as you bring out a 1 over k. Now, what's left over after I use up e to the u is k dx, which is du. So I have 1 over k times this integral. But that integral is just e to the u plus c. And now I'll put back in what u was, kx. So you can think of it like that, or you can think of, instead of multiplying by 1 over k, you can divide by the reciprocal of 1 over k, which is k. The bottom, so let's have the original integral in front of us. You started off with e to the kx, you ended off with e to the kx. But that k magically ends up in the denominator. So that is why a moment ago, when you had e to the negative 2x dx, we ended up with the same thing, and then we divided by the k. But this, you know, I can put the negative on top, or I can factor out the 1/2, the negative 1/2. Either way, we get the same answer. This is a good formula to know. The integral of e to the kx is e to the kx over k plus c. Here's a good one. The integral from 1 to 3 of e to the 3 over x squared dx. Don't let the limits bother you in the least until you're done, and never deal with their limits until you're done with the integration. How about we let u equal the exponent, which is the same as 3x. Well, that's a 1 in the bottom there, the power, so it becomes negative 1 in the numerator. That will be friendlier form for me to take the differential. Bring down the constant, make the new constant 1 less, times dx. So that's negative 3 over x squared dx. Okay, well, this is taken care of. That's e to the u, because u is 3 over x. But what's left over is that. Well, that's good, I have that, but I'm missing the constant. But this just becomes routine now. You can put in the constant as long as you multiply by the reciprocal. So so there's the constant in front. What's in the blue here is this, which is du. Ooh, that's perfect. 1/2 times that integral. That integral is e to the u. Oops, I was going to write plus c, but now we have to evaluate. But remember, that's x there. These are x limits. X goes from 1 to x3. Now, we have two choices from here. We'll do both of them. We have negative 1/3 e to the u. You can substitute back what u was. U is 3 over x. 3 over x. And then we evaluate from 1 to 3. Now, I'd lose my mind doing, if I had to do 3 of these in a row, I'd lose my mind. I can't deal with negatives out there, especially when I'm subtracting. It's going to be this minus something else, and it's going to be negative this minus negative something else. I'm going to get rid of that minus sign. Say bye to it. But I have to interchange the limits. So it's going to be 1/3 times that. Well, first you plug 1 in. 3 over 1 is 3, minus, now you plug 3 in for x. 3 over 3 is 1. There is your answer. That is one way of doing it. The other way was, we had negative 1/3 e to the u. Well, u was 3 over x. Well, the lower limit was x equals 1, and the upper limit was 3. Well, if x is 1, 3 over 1 is 3. And if x is 3, 3 over 3 is 1, so u is 1. Instead, coincidentally, they swap. They did not have to swap. So we used to be going from 1 to 3. Now we go from 3 to 1. Okay? Oh, there's that silly negative in front right there. I'm going to get rid of the negative sign, but then swap the limits. Now these are u values. U is 3. U is 1. I know, it actually says so. So I get 1/3. First I plug in 3. For u, I get u to the 3 minus. Then I plug in 1. E to the 1, I won't write the 1. Okay. How about this question? Suppose you have the integral of 3 to the 4 minus 5 squared times dx, but x goes from negative 2 to 0. What you need to realize is that this is just a constant. It can come in front. Now, 3 to the 4th by definition means this. That's 9 times 9. It's 81. 5 squared is 25. You subtract them, you get 30, you get 56 it looks like. So I bring the constant in front. This just happens to be 56. Then there goes from negative 2 to 0 of dx. If it makes you happier, 1 dx. So it's 56 times this. Well, what is the integral of 1? Well, think about it. What do you take the derivative of to get 1, or 7, or 11? It's that number times x. The derivative of 1x, or x, is 1. And this goes from negative 2 to 0. So there's my 56. First I plug in 0, minus, then I plug in negative 2. I can change addition or subtraction to the other one. In this case, subtraction to addition, as long as I change the sign of the other number. And then 0 plus 2 is 2, so the final answer is 112. And, you know, this makes complete sense. We're integrating from negative 2 to 0 of 56 dx. Well, that's the function. It's a constant. It's always y is 56. And we want the area from negative 2 to 0. We want the area between here and here under this curve. That curve is a straight line. This is a rectangle. The base is 2. The height is 56. The area of that rectangle is 2 times 56, or 112. So we didn't even need any calculus at all to do this, since this was a constant. Even if it were a linear, we can do it, because a linear would give us a triangle or maybe a trapezoid, and we don't need calculus to find the area of a trapezoid. Now, suppose you were asked to find the area between these curves. The curve y is equal to e to the x, and that's always positive. You know, some people will say, no, it's not. If you take e to a negative number, it's negative. No, because there's an understood 1 here. That's 1 over e squared. 1 is positive, and e squared is positive, so the result is positive. So we want the area bounded by that curve, by the curve y equals 0, or if you prefer the line y equals 0, the curve x equals 0, and the curve x equals 5. So, let me just label these y and x, and the curve x equals 0 is this line, and x equals 5 is that line. I'm a little bit to the left of where I meant to be, but that is what it is. And y equals 0 is this line right here. And, you know, if you don't know what e to the x looks like, there's no reason to use derivatives and points of inflection and concavity and our critical values. We know it's positive. Maybe it looks like that. So what we want is, we want the area bounded by the blue curves, the pink curve, and the yellow curve. And that's in here. So each slab goes like this. The first one starts when x is 0, and the last one ends at 5. And they're all delta x's. This means the area is going to be the integral from 0 to 5. It's going to be dx, and what's the height? Well, the height of each of these rectangles I draw, the top is e to the x, y equals e to the x, and the bottom has a height of 0. that each one of them have a height of e to the x. And the integral of e to the x is simply e to the x, and we're evaluating it from 0 to 5. So we get e to the 5, we plug in 5 first, minus e to the 0, but e to the 0 is 1. So this area is e to the 5 minus 1 square units. And if you wanted to graph it correctly, it's not a big deal. It's not going to change anything. It goes like that, where this is the x-axis. I meant to say the y-axis. And then the area from 0 to 5 would just have been in here. And that basically finishes this video.